Today we're diving into a truly revolutionary idea, one that gave AI models like GPT their incredible ability to understand language. We're talking about the attention mechanism. It's really the secret sauce that lets them understand context.
So to really get why attention is such a huge deal, let's start with a really simple question. You have a sentence with the word it. How does an AI figure out what it is actually talking about? For older models, this was a surprisingly tough nut to crack.
For you and me, it's totally obvious that it refers to the animal. But for an older AI, connecting those two words across the sentence was a massive challenge. The context would just get lost along the way, and that revealed a really fundamental flaw in how they were designed to process language.
And that right there is what we call the AI memory problem. It was a core limitation of older models, things like recurrent neural networks or RNNs. See, these models were built to process information sequentially, one thing at a time, and that created some serious bottlenecks.
Think about it like this. The old models process text one word at a time. It's kind of like trying to understand a big, beautiful painting by looking at it through a tiny little straw. You only see one little speck of color at a time, which makes it pretty much impossible to see the whole picture, right? Well, that's what it was like for these AIs.
So yeah, this one-by-one method created huge problems. These models really struggled with what we call long-range dependencies, like connecting it all the way back to animal. They'd often forget the beginning of the sentence by the time they got to the end. Plus, this whole approach meant you couldn't really speed up the training, which made the whole process incredibly slow and inefficient.
So, how'd they fix it? Well, the solution was a total breakthrough called the attention mechanism. And it didn't just fix the memory problem, it completely revolutionized how AI processes information. Honestly, it paved the way for all the powerful systems we have today. So instead of that slow, one word at a time slog, attention lets the model look at the entire sentence at once. It learns to create this dynamic web of connections, figuring out which words are most relevant to each other, no matter how far apart they are.
Right. But the big question is, how does it actually know what to pay attention to? Well, the creators came up with this brilliant analogy. The model basically plays the part of a super efficient research librarian, and it uses three key tools to find exactly the right information: a query, a key, and a value. Okay, so this whole system is built on these three core ideas. Let's stick with that library analogy for a second. Imagine you walk into a library with a specific topic you want to research. That topic? That's your query.
Now, let's go back to our sentence. When the model is looking at the word it, that word becomes the query. It's the model's way of asking, okay, what information out there is relevant to this specific word? Now, to answer that query, the model doesn't just reread the whole sentence from scratch. That'd be too slow. Instead, it looks at these things called keys that exist for every other word. A key is like a little label or a summary of what each word is about. So animal has a key, street has a key, and so on.
And finally, we have the value. If the key is like the title on the spine of a book, the value is the actual information inside that book. It's the rich meaning of each word that the model needs to build a full picture of the context.
Okay, so here's where the magic happens. The model takes its query, in this case the word it, and it compares that query to every single key in the sentence to find the best match. The key for animal is obviously going to get a really high relevance score. So the model then pulls the value, the actual meaning of animal, to finally understand what it really refers to.
And this deceptively simple system of query, key, and value, it had a massive impact on the entire field of AI. It was really the missing piece of the puzzle that unlocked the next generation of language models. Suddenly, with attention, all those old problems just vanished. Models could finally capture those tricky long-range relationships. And because they could process all the words at once, training could be massively parallelized, which made it so much faster. And as a result, their ability to understand context just got stronger and stronger.
And this core innovation, this one idea, is the engine that drives what we now call transformer architectures. Think GPT, think BERT, pretty much all the big-name AI models we hear about today are built on this very foundation. The attention mechanism is their cornerstone.
Now, of course, attention is the heart of it, but it's not the only piece. Transformer models add other really clever layers on top. For instance, there's something called multi-head attention. It's kind of like having a whole team of librarians all researching different angles of your query at the same time, which gives you a much richer, deeper understanding. But it all starts with that simple, core idea of focusing on what matters. So when you boil it all down, by teaching a machine a really simple, intuitive way to pay attention, researchers unlock the potential for all the incredible AI we use every day. It just fundamentally changed how machines read and understand our language, moving them from being simple word processors to sophisticated interpreters of context. Attention taught AI how to focus. The big question now is, what are we going to teach it to see next?